When you look at a painting by Johannes Vermeer, it feels different, doesn't it? There's this uncanny realism, a quality that's almost photographic. And for the 17th century, this was a massive, massive leap beyond what anyone else was doing. It's so precise, so incredibly full of light, that it brings up a question that has baffled art historians and scientists for literally centuries. So how on earth did he do it? How did he capture the world with such breathtaking fidelity, decades and decades before photography was even a thing? Well, to answer that, we're going to have to do a little forensic work. We're going to examine his paintings not just as art, but as incredibly sophisticated optical simulations. And our prime suspect? A fascinating piece of 17th century tech. All right, so our investigation kicks off with the main piece of hardware in question, the Camera Obscura. Now, this wasn't some secret magical device. It was a known piece of optical equipment in Vermeer's time. So what is a camera obscura? Well, the name is Latin for dark room, and that's basically what it is, a box or a room that projects an image of the outside world onto a surface. Now, here's what's so crucial for an artist. It takes a really complex three-dimensional scene and just flattens it. It lets the painter look directly at what scientists call an optical array, a collection of points and patches of light, which is pretty much exactly what our own retina sees. The mechanics here are just straightforward physics. Light from a scene passes through a tiny hole or a lens, and because light travels in straight lines, a full-color image gets projected upside down onto the back wall. An artist could then look at this projection or maybe even trace its outlines, which would make the huge job of rendering reality on a canvas a whole lot simpler. And this wasn't some rare, obscure piece of equipment. The historical record shows us it was actually pretty well known in the Dutch Golden Age. In fact, the incredibly influential scientist Constantijn Huygens was actively encouraging artists to use it. The technology was right there, and people were already talking about how it could be used to make art. Okay, let's move on to the actual evidence. If Vermeer used a camera obscura, did he leave any clues behind in the paint? We need to look for the optical fingerprints, those little telltale signs that can only be produced by a lens. So here is the absolute key piece of evidence. It's an optical effect called circles of confusion. When a bright point of reflected light is just a little bit out of focus in a lens, it doesn't look sharp. It kind of blooms into this soft, blurry little orb. You see this all the time in modern photography. But, and this is the important part, you do not see this with the naked eye. It's a fingerprint, a dead giveaway of a lens. And this is where it gets really cool, because this effect connects directly to Vermeer's totally unique painting technique. He famously used something called pointillé, these little globular dots of thick paint to show highlights. Just look at the bread in the milkmaid, or the sparkles on a tapestry. A lot of scholars believe these dots are Vermeer's artistic translation of the circles of confusion he was seeing in the camera obscura's projection. But here's where it gets nuanced, because he wasn't just a human copy machine. As the National Gallery of Art points out, Vermeer took this optical effect and he ran with it. He started applying these circular highlights even on matte, non-shiny surfaces where they wouldn't naturally happen. So the camera might have shown him a new way to see light, but he was the one who adapted that vision for his own artistic goals. Now let's pivot. We've talked about the physics of light, so now let's dig into the mathematics of space. Because beyond the way he painted light, there's the absolutely jaw-dropping geometric precision of his rooms. I mean, just look at this. Look at the floor tiles, the map on the wall, the placement of the furniture in the art of painting. The perspective is pretty much perfect. And that's a level of accuracy that was just incredibly difficult to get with the normal draw-it-by-hand methods of the day. How perfect are we talking? Well, get this. Computer analysis of the floor tiles in that exact painting found a mean error of just plus or minus 1 millimeter. 1 millimeter. That is an absolutely astounding level of precision for someone in the 1660s. So how did he pull it off? Well, this is where the debate gets really complicated. On one side, you have researcher Philip Stedman, who did this incredible work showing that if you reconstruct Vermeer's rooms, the image projected by a camera from one specific spot would perfectly match the size of his canvas. That's pretty compelling. But on the other hand, when he died, there was no camera obscura listed in the detailed inventory of his stuff. And we know artists at the time could use a simple pin and string method to create straight perspective lines. But here is a key technical difference, and it's a big one. When you draw a complex grid of lines by hand, every tiny mistake you make builds on the last one. The errors are cumulative. They add up. With an optical projection, though, every point is independent. The errors don't add up. This gives you a much, much higher level of overall accuracy in a complicated seam, and it's a really powerful argument for him getting some kind of optical help. So we have optical evidence, we have geometric evidence, but a painting is also a physical thing, right? So let's shift our analysis again, this time to material science, to the actual chemistry of the pigments on his canvas. And there is no better example of this than the iconic headscarf in Girl with a Pearl Earring. That absolutely stunning, vibrant blue comes from a pigment called natural ultramarine, and the way Vermeer used it was, well, totally unique. Now, this wasn't just any old blue paint. No way. Natural ultramarine was ground up from the semi-precious stone Lapis Lazuli, which had to be imported all the way from Afghanistan. In the 17th century, it was literally more expensive than gold. And Vermeer didn't just use it for blue things. He mixed it into the shadows of white walls and gray areas to give them this cool, luminous quality. And get this, scientific analysis shows he used an exceptionally pure, high-quality version of it. Okay, but this brings us to a major, major problem for the Camera Obscura theory. While the device is great for getting lines and tones right, it's actually terrible for color. I mean, imagine trying to figure out the true color of your paint while it's being bathed in the colored light from the projection itself. For a master of color like Vermeer, the Camera Obscura would actually make his job much, much harder, not easier. So, where does all this leave us? We've got evidence for, we've got evidence against. Let's try to bring the optics, the geometry, and the chemistry all together and see if we can reach a verdict. You know, I think this quote from Philip Stedman really gets to the heart of it. Maybe Vermeer's true genius wasn't in tracing an image, but in understanding what the camera was showing him. He figured out that if he could just accurately paint the tonal values, the relative brightness and darkness of the patches of light, the viewer's brain would automatically do the rest of the work and build the scene. He was basically simulating how we perceive the world. So the most likely answer is that he was this brilliant synthesizer of different methods. He wasn't a passive tracer, not at all. It's totally plausible he used the traditional pin and string method to lay down the rigid mathematical skeleton of his painting, and then he used the Camera Obscura to study the light, the tone, and those cool optical effects, using it to apply the skin to that skeleton. And that's the key takeaway here. The final painting is always an artistic interpretation, not a simple replication. He saw those circles of confusion and transformed them into his signature style. He studied the flattened image to perfect his tones. He was this active, intelligent interpreter of optical data, and he used it to create a reality that somehow feels even more real than reality itself. So, in the end, our forensic analysis shows an artist at the absolute peak of his powers. Vermeer used the technology of his day not as a crutch, but as a tool to unlock a completely new way of seeing the world. He then took that unique vision and combined it with flawless technique and the best materials money could buy. He proved himself to be a master of both art and science. And all this leaves us with one final thought, one that resonates just as strongly today, I think. In any creative field, whether it's 17th century painting or modern AI-generated images, where exactly do we draw the line between an artist using a tool to bring their vision to life and the tool starting to define the art itself?